materials and calendars of, for instance, the moon's phases. It's also historically not been distinguished from mathematics and from astronomy. Much of the earliest and most interesting historical mathematical work was related to questions like predicting the eclipses. And many things that survive in today's mathematics, such as our system of 360 degrees in a circle, descend from astrological considerations. It's not mentioned on the slide, but I should also mention that there are parallel astrological traditions in different cultures. I'm primarily going to talk about what's called Western astrology, which is the astrology of Western civilization. But there is also something that people call Hindu Vedic astrology, which has some similarities and some differences. And there is a tradition in East Asia, primarily of Chinese astrology. From a typesetting perspective, what's really interesting for us is that astrology has its own symbolic notation and visual language, and with special typesetting needs that are of interest to technicians. And honestly, that's one of the biggest attractions of it for me. I really like anything with a visual language, and that draws me to Japanese, music, astrology. So just to give us a frame of reference, I'm not going to go into yet what the denotative meaning of this diagram is, but this is the kind of thing we are going to be generating with the horoscope and star font packages, okay? This is a mundane horoscope of the TeX draft from May 13, 1977. Knuth's one of his first documents that he generated describing what TeX would be all about. I didn't have the time of day. I'm not sure there would even be a meaningful time of day for that one event in time. So this is just cast for noon on the recorded day in Stanford, California. We'll come back to that chart later. Stepping back and looking at the LaTeX packages that I'm describing, here are some sort of terms of reference for those packages. I've got two packages. I've been working on them in some form or another since about 2003. So these are fairly mature packages. They are now both in CTAN. These are written as classic LaTeX, okay, with the line 2 and curve 2 and whatever else. They're not actually using TeX. Get to why later. The focus here is on typesetting. So the story is you are writing an astrological document. Maybe you are a professional astrologer, you're doing something for a client. You already know what you want to typeset. This is now about making a pretty picture out of it. So I am not going very long on features for like exploring different, astrologers will typically cast several charts for different times or whatever to try and find what best illustrates the point they're going to make. We are at this point past that level. We are at the stage of generating a nice document when we already know what we're going to say. We can compare that to the situation, for instance, with music typesetting, where if you have a package like Lily Pond, it's for engraving a pretty score, but you had better already know what you want it to look like. It's not a nice editor for writing music. So there's this focus on typesetting. There's a focus on customizability, because especially if you're writing a longer astrological document, if it's the sort of thing you might want to use LaTeX for, maybe you're doing something new and innovative. Maybe you're writing about the astrology of the asteroids, or heliocentric astrology, which is displaying things from the point of view of the sun rather than the earth, or some of these more unusual things. So it's likely that you may have special needs that are not even just a standard classic astrological chart. So there should be some ability to customize. Nonetheless, I want the default charts that come out of this to be best of breed. It's a fact that's, relatively few serious astrologers are also experts on TeX, and so I don't want everybody to have to dig into the internals of the package in order to use it. So these are sort of the terms of reference of where I'm coming from with designing this code. Now I will give you just the very brief astronomy lesson. orbital mechanics is potentially very complicated. Much of this work was done by astrologers in order to cast charts, although it's now used for a few other purposes as well. If we look at the inner solar system, which is shown sort of schematically here, we've got the Sun in the middle, and Mercury, Venus, Earth, and the Moon are sort of a double planet, and Mars there. And this is basically a flat object, okay? All of these planets go around the Sun in different orbital planes, but all nearly the same orbital plane. So we can kind of approximate it and say the whole thing is flat. Nonetheless, the Earth also rotates on its axis, and that axis defines another plane, the plane of the equator, which is tilted 23.4 degrees at the moment relative to this plane. So if we are looking up in the sky and we want to say, where is a planet? Well, we know it's probably going to be on that flat plane, the ecliptic plane. We don't really care how far away it is because you don't see that when you look up in the sky. We only really care what angle is it along the ecliptic. So here's a sky chart. It didn't come out wonderfully well on the projector, but you can probably see this is drawn such that the equator is a straight line across here. The ecliptic, remember there are 23.4 degree tilt between the two. This is the path, effectively, that the Sun passes through relative to the distant stars. All these dots in the background are the distant stars, which on a human time scale, they basically don't move. Just a few have some barely measurable motion, but you can pretend they're a fixed frame of reference. The apparent position of the Sun against that background as we rotate around it, or revolve around it, it traces out this path, which looks like a sine curve on here just because of the map projection. Really, that's just a circle in the sky. Effectively, it's another straight line. So over the course of the year, the Sun goes like that. The other planets travel along this same path, more or less. They go up and down a little because the thing is not really flat. But basically, if you want to know where a planet is, what you care about is what is its longitude? Where is it along this path? Okay? But because it's a circle, you have a question of what's the reference point. When I say it's at longitude 37 degrees, where is that? Where is 0? In Western astrology, the standard is that we measure from this crossing point. Okay? That is, right here is the spring equinox. And when the sun's path crosses the equator, we call that the 0 degree point. That is the beginning of the sign of Aries. Now, partly to facilitate hand computation, we don't just count degrees starting from here, because then you'd have, degrees up to 360. We split the ecliptic into 30-degree segments, okay? And each of these segments has its own name. There are 12 of them. And then we say how many degrees and how many minutes and seconds are we into the segment, the sign. Those segments have names: Aries, Taurus, Gemini, and so on. And this is something that really winds people up. Those names, you may see there's small print on here corresponding to the names of constellations. In general, the names of the signs are the names of constellations also, but they're not in the same place. Because this reference point moves very slowly, but it does move. It moves 1 degree per 73 years. And so as a result, the sign of Aries, which is by definition 30 degrees starting from the spring equinox, right now it starts somewhere in Aquarius. You may have heard the term Age of Aquarius. That's what it means. It means the equinoctial point is currently in the constellation of Aquarius. So, don't be too confused that you have these names that are also the names of constellations, but we're not talking about constellations. We are talking about 30-degree segments, because that makes hand computation easier. If you know those names by heart, then you can easily compute how far apart are two positions given by sign and degree. So with all that in mind, now we can look at this as the same chart from before, and we can get maybe a better idea of what it signifies, okay? In this chart, we can be imagined as being somewhere far above the North Pole of the Earth. And we're looking down, and everything has been sort of flattened. We're looking down at Stanford, California. Here's the sun. It's above Stanford because I cast this for noon. Here's the eastern horizon. Here's the western horizon. Here is the nadir, the bottom of the going down into the earth. All of these objects around here are things in the sky: the moon, Mars, Venus, here's Saturn, and so on. Over the course of a day, almost everything on this chart will move clockwise. Okay, Saturn has just risen maybe 30 or 40 minutes ago, and here the moon is going to set in, let's say, an hour. So as over the course of the day, things move clockwise. Over the course of a year or an orbit, things generally move counterclockwise relative to the frame of reference designated by these signs around the outside. Outer ring is the 12 signs: Aries, Taurus, Gemini, Cancer, Leo, and so on. So that represents our cycle of the year, or 360 degrees. These arrows are not, you've noticed, precisely at right angles, because that is an effect of the axial tilt. As we try to squeeze everything into a flat plane, it has to be adjusted a bit. We in astrology tend to be very interested in which of these signs is an object in. So the fact that the moon is in Aries is of some interest. But almost everything on this chart would be true everywhere in the world at this moment. So if we want something that is more personalized and specific to this particular location and event, then we have to come up with something else. And the way that's typically done is with these additional lines here. These are the house cusps. The exact definition of these can be quite complicated, and there are different schools of thought, but in general, you come up with some way of dividing the sky locally, as seen from Stanford, into 12 segments, which are sort of analogous to the 12 signs. And then we designate things into these segments. So here, because it has just risen, Saturn is in the 12th house. They go 1, 2, 3, and so on up to 12. In the center, these lines show when there's a close angular relationship between two things. For instance, it's interesting that Neptune here and Mars are almost exactly a third of a circle, 120 degrees apart. That's called a trine. So there's a line connecting them with this trine symbol on it. So that is the information presented in this chart. Now I can show you a few other charts. This one is Kurt Cobain, who was the voice of his generation, and I was never a fan, but I clearly remember the day he died just because of the effect it had on all the people around me. And this gets into some of the things that we might think of in the artistic side of astrology. Cobain has this grand trine. Jupiter, Neptune, Venus and Saturn conjunction, they're all in 120 degree relationships to each other. And they're all late in the water signs. That's a very strong connection to emotions. And it's funneling power into the planet Uranus, which is right on the ascendant, just rising as he was born. This is someone who spoke a lot about the emotions of everybody in his generation, but it was tied to his individual presentation as seen in the ascendant. And then, unfortunately, but it makes for a good chart, here's Pluto, the planet of death, just rising at the moment he was born. So those are the kinds of things that an astrologer would look for in a chart. Now here's another musician, and this is, as you can see, plotted in a very different style of chart. This is some of the customization of the horoscope package. Jimi Hendrix, this chart doesn't have the rulers and the detailed aspect web in the middle. This would be a chart appropriate for someone who wants to do an interpretation that's more personal and based on these houses. It really emphasizes what houses things are in rather than their exact longitudes. Here's a chart. I had to look up what her last name is, but this is the performer Madonna. And this chart style is based on some historical examples. It was actually what I was trying for when I designed the previous chart, which has a different layout of houses. And one thing you can see here that's sort of interesting, we've got a whole lot of stuff packed into this 12th house, okay? And if I try to plot that on the sort of standard default chart, here's what we get, okay? I have actually seen software that purported to be professional grade, that if a house was overfilled, it would just move the object into the next house, which is a disaster, okay? It makes it completely meaningless astrologically. You have to do something more like this, even though it's a little ugly and is really difficult to program, you have to expand the house. I added Roman numerals there to make it even more cramped to demonstrate, but you know, this house cusp is there and it jogs out to make room for all the stuff packed into Madonna's 12th house. So that nicely points towards some of the, first let me show you some of the competition, okay? This is what we might call brand X. This is a free online chart from a major commercial astrology company. And in fact, this is not even the default. I had to edit their default options a little to try to make it as comparable as possible to mine. I don't really like this font. This aspect web is cluttered with all these extra lines that don't need to go through the middle. On the whole, though, I mean, it's certainly recognizable as an astrological chart. A lot of people are happy with that. And they give these away largely to encourage you to buy their commercial services. Here's brand Y. This is from free desktop software, again, a very popular package. And this one, the colors are a little washed out on the projector. I tried to edit them to make it look as nice as possible. Really, this is designed for interactive use, and it would fill the entire screen with a black background. So it actually looks better when it's used as intended. Also, although it doesn't have labels showing the numeric values, in actual use, the interactive software has another section to its display, so you can see that all separately. So this is actually better than it looks. But you know, I still think that for typesetting, I like mine better. This is one from a commercial Windows software package, costs $360. It was a little hard for, those last two that I showed you were actually the same chart as that tech draft. This one is just whatever I was able to find on the web as a demo, because I don't have a package. I like this one the best of those three, and you can see it's a whole lot like mine, okay? It's got the aspect web in the middle, it's got the numeric labels, it's got, which is kind of nice, it's got the all the house cusps given numerically around the outside there. So this is pretty good. I don't know if it's better than mine. It's certainly more expensive. And I think it's less customizable. All right, so now let's talk about the challenges that have to be solved for astrological typesetting, creating these kinds of charts. One thing is fonts. It's really important to get a font that has those astrological glyphs and has them look nice and work well with each other and with text fonts. You have to actually do the astronomical computations and figure out where all those objects are. There are some issues of layout. How do you actually put things on the page? Remember, I'm not using TeX. I'm using classic LaTeX, which doesn't actually do polar coordinates, which is what you want. There's an issue of colliding labels. If Venus and Mars happen to be right on top of each other in the sky, that's astrologically very important, but you don't want to plot the labels right on top of each other. And this is behind the scenes, but there are interesting questions about how you round numbers to lower precision. So fonts, you could just use abbreviations in your text font. That looks okay, but it's not as nice, right? WasiSim is a very popular LaTeX package for symbols, and it has a basically full set of astrological symbols. I actually like the design of these symbols, but there are problems. These outer planet symbols are not the most common or popular ones. Also, this here is a really big problem, okay? That is supposed to represent the equinoctial point. I'm sorry, the north node of the moon. Anyway, you may note this symbol looks exactly like this symbol. They are actually the same symbol. The macro is aliased. That's, you know, you show that to an astrologer, they'll just laugh at you. Okay, so here is MarvoSim. This is, I like this design. It's a sort of a brush stroke design, but it doesn't fit very well with text fonts. Also, it only has the signs and the planets, so this is not a perfect solution. Starfont is probably the best I've been able to find. Kind of a nice story here, the font was being passed around on the net, probably against its copyright, as just a naked TTF file. And I wrote LaTeX bindings for it because I wanted to use it. CTAN wasn't thrilled about distributing it because it was probably against copyright. Anyway, eventually the designer of the font, Anthony I.P. Owen, happened to spot his name in a Google search in the documentation of my LaTeX bindings. So he contacted me and we talked about it, and he agreed to release the font as public domain. So now it is in CTAN and you can all use it, and that's great. So that is probably the best font I've found. It's still very bold. Some of these, it doesn't fit so well with other text fonts. Some of these symbols are not exactly the design I would choose, but they're still pretty good. How do we do the astronomical computations? Well, the way I do it is I shell out to some other external software. And I offer a choice of Swiss Ephemeris or Astrolog. So it's just using the standard Write18 interface to go run this other software which writes a file which then gets read back on a second run of LaTeX. This is all pretty predictable. Optionally, we can run that file through egrep to try and remove any extra messages that the software sometimes generates, which is good because then you're more likely to get reasonable results from it. But for the most part, I just push all of the questions of how to get correct data to the external software. And I also don't handle anything like time zone conversion. You just have to enter it in whatever format the external software expects. This is typesetting. This is not computation myself. It would be fun to try to do all the ephemeris computations in plain tech, but that's not my main focus.
Are you sure?
Yeah, I've done enough other stuff, similar things, including, for instance, polar rectangular conversion. So I have some idea of what would be involved. It would be possible, it would be an interesting challenge, but it's not really a high priority. I'm using some internals of the trig package for the polar coordinates. I'm using the PIT2E package, and I was very pleased when that package actually got implemented, because it was promised for a long time and didn't exist. Why not use TXE? One reason is because it didn't exist in its current format when I started this. Also, I was very interested in sort of learning the classic LaTeX ways of doing things. Colliding labels and cusp shifts. I only have a couple points on the slide here. It's pretty much what you would expect, although it ended up being a fair bit of work to implement. It's a spring tension system. You know, each label has a certain amount of springiness. It's being pulled towards where it should be in its longitude, but it's being pushed away from other labels. So it then iterates a bunch of times through these moving things according to the spring tension until it comes up with a reasonable solution. It does two passes. First, it tries to keep all the cusps straight. If it can't fit that way, then it allows them to bend, as you saw. Rounding, I'm not going to go into all the details here, but first of all, if you want to represent something just by the degree it's in within a sign, fine, you round off. The trouble is, if something happens to be very near the end of a sign, if someone was born in late April, just before the Taurus cusp, we don't want to call that Taurus. We want to call it Aries until the moment it crosses the cusp. So you can say, well, we'll truncate, but then you've got up to 1 degree of error and you've got issues with averaging out truncated values. You say, well, we'll truncate only at the end. Then you could have as much as 1.5 degrees of error. Probably the best thing to do, although it's a little unfamiliar, is say that the very end of Aries will be called 30th degree of Aries, which is an alias for 0 degree of Taurus, but it tells you which side you're on. That is covered in more detail in the manual. I have a code example. This is what it looks like to actually do the computation using an external backend. You specify the time and location, you specify the objects you want unless you're using the default, run this horocalculate, which does call the external and read back, and then it typesets it. I have another example here. If you didn't want to use a backend, if you wanted to write a document that could compile without a bunch of astrological software, you can manually define all the things the backend would calculate. And I have a final slide here of what are some future possibilities. As I was working on the slides and preprint for this, I found some errors in the documentation which will have to be fixed. It would be nice to have externalization a la TeX, where you can generate that manual stuff automatically to create a standalone document. It would be nice to have more in the way of manual tweaking to say, well, the spring system didn't work for this one object, I will move it a little bit by hand, or I want to add some pointers and arrows to here are interesting things on the chart. And if this were to be used by someone who's not an expert on tech, it would be nice to have more in the way of interpretation and packaging. In principle, you could write a document that would automatically detect where everything is and load a bunch of text snippets and generate an interpretation. I mean, not many people are willing to do that much work to generate to write all that text unless they're being paid for it. But people who are willing to do that and have the skills can be paid for it. That's how the commercial astrology companies make their money. And so that's where we're at. And if we have time, I'll take your questions.
Okay. Lots of questions?
Yes.
I think one of the most fascinating aspects and the circle has to be laid out is the baseline of the description of the position. It's actually, the baseline is not horizontal, it's not vertical.
Right.
It's a radius.
Yes, let me show you.
The objects are sort of piled up.
Yep, and there's an interesting detail there. Look here at Venus and Mars, okay? 12 degree Aries, 54 minutes. 12 degree Aries, 26 minutes. They're going in opposite directions because I'm trying to keep it top to bottom, right to left. I don't know if any other packages will do that.
You've got to take into account the cap height of the symbols.
Yes. It's less smart than it looks, okay? I've really just said, well, these have to be at least a certain number of degrees apart. So it's not really knowing how wide they are. But, you know, the direction reading thing, that is explicitly done.
That's fascinating.
Further questions, comments? I like the idea of auto-generating.
Yes.
I mean, we did this for our proof theoretic system, which was throwing a system and it generates a complete paper which you can submit as is to a journal. So it might be a good way to make money.
Well, yeah, and then you can hire a human to. Well, talk to me later.
Okay, let's thank Matthew for this nice talk. Do you find this? This is fine. You have a connector.
No, I have this connector right here.
Ah, okay.
All right, that goes in here. Yeah, it's not working right. Maybe.
Yeah, that's fine.
Okay, that goes into USB.
I don't know which.
This one over here too. It's just an ordinary USB connector. Just this is not a USB. No. Oh. Oh, the worst.
No, this doesn't fit into USB. This is a mini HDMI.
Maybe how close?
Anyone has a VGA to HDMI?
Or can I use somebody else's computer? I just have PDF.
Mine doesn't work, you said?
Mine HDMI to VGA?
Yeah. Yeah. No. What?
Is that wrong?
This is the wrong side.
Okay. No, hang on. What are you doing? No. Is he got HDMI out?
Yes. Yes.
Okay, here we go.
That doesn't. Ah, okay. Yeah. Well.
Okay, distance.
Wanna have a try?
Okay. This should fit here then. Now the HDMI was on this side. Yes. Yes.
Excellent. Now we have something. Okay, good. Thank you. Thank you. All right, let's just open this up. First of all, right.
So the next speaker is David Tulett, and he will speak about ebook preparation.
All right.
And I hope to manage.
Oh no, it's wrong. Heck. Yep. Just a second, I hit the wrong file here. TUG Acrobat. Thank you. Help me out. Why is it not?
I think it's already open.
Yeah. No,
this one?
that's my main file, but I can't. Just click it again.
Double click again. Yes, now it turns around.
That's my main paper. Oh, there we are.
Yeah.
Excellent. Okay, sorry for the delay in getting started. My name is David Tulett. I live in St. John's, Newfoundland, which is the most easterly city in North America. And I work for... it was okay the way it was. Let's just leave it like... Okay. I work for Memorial University, which is the largest university east of Montreal. And in particular, I work in the Faculty of Business Administration. And I teach and do research in making mathematical models for business problems. Every 10 years or so, we take a look at our curriculum and try to keep it current. And as a consequence of that, we developed a new course called Business 2400. I should explain here, I don't actually have slides. I have the PDF file. I've never used PowerPoint in my life, and I haven't gotten to use Beamer either for the same reason. I actually like my students to look at me and not look at that, but I will go to that when I come up with something that needs to be seen. So anyway, this new course, Business 2400, if you've taken a course in optimization, then these topics will seem familiar. Linear optimization, or linear programming is often called, integer programming, decision tree models, network models, and so forth. Yes? Oh, sorry. I need to be here, don't I? I'm sorry. I didn't realize that. Yeah. Okay. Those topics have been taught for years, but what's new about this course is that we decided to de-emphasize the teaching of algorithms. So one time we actually taught how to do the simplex algorithm, the branch and bound algorithm. Those topics are moved to an elective later in the program. The focus now is on modeling. So if you think of a paradigm for this kind of field where you take a business problem and then you make a mathematical model of it, and then from the model you get a solution technique, and then you can talk about implementation, and then ask the question of the implementation address the original problem. In that paradigm, it's that first linkage. It's taking the problem and making a mathematical model that's the most important element. Of course, we're not actually going into a business and doing this. These would be seen by students as what they would call word or story problems, and they would make a mathematical model. And most of the time, we would just allow the computer to solve these problems. The exceptions being two-variable linear optimization by hand, a visual algorithm for the minimal spanning tree problem, and the rollback procedure for decision trees, which are all simple algorithms, but otherwise we're emphasizing modeling. So this course began in 2011 on campus and was to be offered by what is now called online learning, then called distance education, for in winter of 2012. And because of that, I wanted to develop a book for it, develop a set of course notes, because these people would not be in class to get a set of notes as students would normally get. So we had a textbook adopted for the course, as I guess most universities' courses do. If you're not used to being in the university environment and you're used to prices in ordinary bookstores, you'll be shocked if you go to a university bookstore just how expensive books are. I'm thinking in terms of Canadian dollars, but something like $200 Canadian is typical for a book, and they can be less, but they can be more. Anyway, so here I am. That's what I want to do. I want to create a book which is going to be like a substitute set of course notes, and of course it can be given to the on-campus students as well. There's really three places where I could have talked about this topic. I could have gone to something like the Canadian Operational Research Society, or INFORMS in the United States, which is concerned with the areas that I mentioned about linear programming and so forth, and talk about it in, say, an education stream. I could have also talked about it in an open access discussion, maybe among librarians or something, because they were interested in the fact that I'm giving the book away. And the TeX is another possible, because TeX is the component of it. And the reason why I presented at TUG is because this year of all years, you're coming to Canada. I thought, well, I'm not missing this opportunity. If it had been in Holland or, or India or something, I might have done it somewhere else. But so anyway, here I am. What I want to do now is talk about the structure of what's to follow. I want to discuss why LaTeX. Well, I'm saying LaTeX, because I've always understood it as layered tech, but I hear everyone saying LaTeX, and someone else said latex yesterday, so I'm not really sure of the official pronunciation, but I've always called it LaTeX. Why that as opposed to...
Leslie called it LaTeX.
LaTeX, okay, all right. All right, LaTeX it is. I'll try to remember that. In the middle of the presentation, I want to talk about issues that came up. My interest isn't tech in itself. It's tech is the means to the end to get a book published, and that issues that came up in doing this that aren't something you'd find in the tech manual, and I'm a lone wolf in terms of the department of using tech. And thirdly, I want to talk about open access and why I went that route. All right, first of all, let's talk about why LaTeX was. The other choice is Microsoft Word. I'm going to give myself away here by telling you my nickname for Microsoft Word is Microsoft Weird. I don't really like it, but it is the standard where I work. It's given away. Microsoft Office is given away to all professors. I don't even have to download it. Somebody will come up and put it on my machine for me. If I have a problem with it, someone will come up and fix it. It's given away to all the students. If I have a problem with LaTeX, they'll say, that's your problem, sir. There's no support for it. The only support I get is that I'm not fired for using LaTeX, but I can use it, but that's about it. So I do use Word a fair bit, especially for any collaboration with other people. So one thing that was important here is I'm writing the book by myself, so that the collaboration thing wasn't important. Just the other day, I was filling in a report, what I have to do with, I have to put up an annual report every year saying what I've accomplished. And I had 4 things listed, and I saved the file, went back to it to put down the 5th thing, and it wrote 4. Hang on, how do I get 2 4s? I had tried to overwrite the 5, and then it changed the typesetting and went off to do something else. I finally had to kill the automatic renumbering and call it 5. I don't think in LaTeX, if you're in the enumerate environment and you use an item, you could actually create 2 4s in a row if you wanted to. I don't know how it's possible with Word. So it's just a reminder that I think tech is a better product. I just think in terms it's beautiful in terms of math and it's structured. It's also the fact that I'm creating a new book, but I'm borrowing from sources. I've been professor for 31 years, and I've written stuff all along. So I might want to take the new document, take chapter 7 from this book becomes the new chapter 2 more or less, and chapter 3 from that book becomes the new chapter 8 more or less. Now if I was in Word and I tried to do that, would the footnotes all be numbered correctly? Would the tables be numbered correctly? Would the figures be numbered correctly? Or would even the chapters be numbered correctly? I don't think so, right? But in LaTeX, because none of this stuff is put in by hand, when you switch stuff around, it's all done automatically. So I said, I'm doing it by myself. I think it's a better product, and I went with this. Now I want to go through a couple of problems that I came up with, and I know someone said describe this audience as being geeky, and if so, you probably already know some of these topics. Let me. So I want to go through two problems. There's probably about a dozen places where I just found a little bit challenged on how am I going to do this easily. And here's one example of something. It's called the assignment problem. In an assignment problem, you have n things of one type trying to match up with n things of another. So in this particular example, n is 3, and I'm trying to put 3 jobs in 3 machines, and the numbers in the main body of the table could represent time in seconds or minutes, or it could represent dollars, for example. So one solution might be to put job 1 on machine 1, job 2 on machine 2, job 3 on machine 3, and that would cost 30 plus 40 plus 28 is $98. Okay, not a good solution. How many solutions are there? Well, when you have n things, there are n factorial ways to solve it. So n is a very small number, and 3 factorial just sits. Well, so one easy way to solve this problem, write out all 6 possible solutions and pick the one which is cheapest, which happens to be put job 1 on machine 2, 2 on 1, and 3 on 3. 37 plus 28, that's $65. But if you're going to try to solve 10 jobs and 10 machines, you have to formulate it mathematically. And in the mathematical formulation, you have double subscription xij. It's a 1 if job I is assigned to machine j, and it's a 0 otherwise. So I'm defining 9 variables. And that means I have an objective function, and the body is what I want to minimize. I'm taking the cost of assigning job 1 to machine 1, which is 30, multiplied with the x11, so it's either 30 times 1 or it's a 30 times 0, and doing that for all these combinations. And that I want to minimize, but I need to do that subject to some constraints. But I'm going to have to first to have some constraints to make sure that every job gets done. So x11 plus x12 plus x13 equals 1, and forces one of the job 1 has to be done somewhere. Yeah, there are pluses, yeah. And this. And then to make sure every machine has a job assigned to it. And of course, the restriction that all the variables have to be either 0 or 1. Despite the fact that it's got this binary integer stuff, that's in fact, this is in fact a naturally integer program. Even if you don't specify the last line, it will work out that way. Now there's all sorts of packages that can be used to solve this, but we're going to use Excel. And the reason we use Excel in the business school is because Excel is a ubiquitous business software package. The students have it anyway, and most businesses have it, and so it's transferable. If I use something else, they'd have to download it, pay for it, and so forth. So I can put it onto Excel, and this is what it looks like. Oops. That's the solution. Just a second now. All right. So what I have here is the cost data are in the bottom in that blue section. The yellow is reserved for Excel to put the answers in, the zeros and the ones. And I have all these restrictions. I want the sum of each row to be a 1, sum of each column to be a 1, and I want to minimize that cell, I think it's A11. And that sum product function is not just the dot product of a row and a column as it's normally done. It's actually taking a matrix times a matrix in a way, but it's not matrix multiplication. It's cell 1 times cell 1 plus cell 2 times cell 2 and so forth. All we have so far is a giant calculator. In order to use this, you have to use this thing called a solver. If you've never used it, it's an add-on to Excel. You have to go in and add it in, and you specify that you want E3 to equal G3 and so forth. Specify those relationships and say you want to minimize that cell A11 and allow it to fill in those cells, and it will fill them in, and it looks like this. So there's the solution. The optimal cost is 65, and there's the optimal solution is given up here. 1 goes to 2, 2 goes to 1, 3 goes to 3. Now, what I want to talk about as far as the tech was concerned, especially for the one before, now I started by doing this by using the tabular environment, which works because it's got horizontal lines, vertical lines, and even the colors are okay because of color TBL package. I can mimic this Excel output using the LaTeX tabular environment. However, it takes a long time. And also, the colors will never quite match Excel's colors. You can play around with this RGB stuff and create magenta and so forth and try to create, it's hard to create exactly. Also, it doesn't quite look like Excel. Now what you actually see here is Excel output. It took me a while to figure out how to do this. So first of all, in Excel, I'm using Control tilde to create the display of the formulas. And the big thing I needed was to print this in Adobe, but to not just have the reader as I had, but to go and spend the money to buy Adobe Acrobat, which can crop these things, and I cropped it to fit and then used an include graphics command to do this. So that's how I decided to handle every Excel file, is by doing that procedure I just described, not by trying to create the tabular environment. It's much, much faster, and it also then looks just like Excel. So that was one challenge that I didn't see it described anywhere in the book, so I had to teach myself that. This. So here's a word problem that I'm going to solve, and we'll solve it graphically. Okay. Company's making 2 types of spindles. Type 1 spindle, 6 cuts, 4 minutes of polishing, 6.5 minutes of varnishing. And a type 2 spindle, 15 cuts, 4 minutes of polishing, 4.75 minutes of painting. Home cutting machine works 135 cuts per hour. One polishing machine up to 54 minutes per hour. You can handle 1 spindle at a time, and certain hours of operation of 55.8 and 57 minutes per hour respectively. And some financial information. How much money do we make for these things here? $3, $4 for type 1, type 2. And the answer to these kind of problems isn't something simplistic. We'll try to make as many you can of type 2 because you make more money because you've got these restrictions. What we do is make a mathematical model of this. It's almost simple enough that you could go from this model, this word model, to an Excel model in 1 step. But I think that's a bad habit, because once you get more complex problems, you have to have the mathematical model. So I define the variables, x1 and x2. All right, because it's got just 2 variables, it means it can be graphed, number of spindles of each type produced per hour. Okay. So it looks like that. So this is obviously done in an array environment. I always think it's in a good form to line things up so they have the small problems. Put a word. You can get away with just writing 1, 2, 3, 4 for constraints, but I like to put words on so that when you look at the model 3 weeks later, you can remember what it's about. So cutting, polishing, varnishing, painting, these are the descriptions. They're all inequalities. So maximize a linear expression subject to 4 inequalities, and the variables have to be non-negatives. All right, so to solve this, I'm going to do it on a graph. Now, when I first started this, I just said, okay, I'm going to do it by hand, and this, save it as a PDF and include it. I was really rushed at the beginning and trying to get something out to the students, but then I start to go back and do it in PS Tricks. Now, I heard all this stuff about TeX and so forth. I don't know if it's better. I don't know it, so anyway, you can tell me if I'm using the wrong package, but I went to the trouble of learning a lot about this PS-Tricks package. So I want to just show that diagram. In order to make the diagram, I do a bit of pre-processing. I have to figure out how to plot these things. So you're trying to plot an inequality. So the way to do it is to plot the boundary of the equality and use an arrow to indicate which side you want to be on. So for these points, what I tend to do is pick a point that's on the axis, like 0, but make one of them 0 and the other has to be 9. But I've done a bit of pre-processing to figure out, look, because of that second constraint, it's obviously not going to exceed 13.5 for either variable. So have a 14 by 14 grid, I can get everything on. And so based on that, I run out of room if I try to make the other one 0. So I make one 14 and I see it's 3.4. The other one works out with zeros and zeros, and then one line's horizontal, one line's vertical. And now I can start to plot these things. Probably should do it. There's a better choice here. I want to get it all. I want to get it all on. All right. So it creates the lines by. That's easy enough to do. Give the endpoints, and the polygon that's filled in, what that means physically is that this is a set of all points which are feasible for the problem. Of course, we want the point that's optimal, and so that's found by making a line to represent lines of equal profit in this case, and optimize it by taking it up to just about to leave the feasible region, and there's the optimal solution. Maybe we should go back to 100%. That's actually tiny. Yeah. Now the polygon is actually requires a bit of pre-processing, because it wants to know the PS-Tricks wants to know the coordinates, but everything is solving two equations and two unknowns. So you have to do that by hand. So I was thinking, if I was ever going to write some kind of macro, it would be like, how would you write a macro that actually creates the coordinates for the polygon, not have to do it by hand? Anyway, that's a minor point, though. You go and solve that. The greater challenge for me was I wanted to write the words on the lines that are slanted at the same angle as the line. And I'm 62, I'll be 63 on Thursday. I studied trigonometry when I was 15 or 16, and I haven't seen it since. And I wanted to create the right angle. Let's take the cutting constraint as an example. It took me a while to figure this out, but here you have a 6 there and a 15. You take the coefficient of the horizontal variable, divide it by the coefficient of the vertical variable, and you want the arctan of that ratio, and then, which you can find in Excel with atan command. Then I discovered that why is it not working right? It's because in Excel, the default is radians, so you have to multiply by 180 divided by pi. And this is like 4 decades ago for me for all this sort of stuff. So this was a bit of a challenge to get this to work. But in the end, it was fine. The PS-Tricks package does work. It's slow. One thing I've done and is not try to write the math. The whole book is 550 pages. Don't try to write it in PS-Tricks. I'm using PS-Tricks just to to do the diagrams separately. And when the diagram is finally right, I got a PDF which is cropped and imported. Okay, thank you. Okay, so that's all right. That ends the second part. I want to go to the third part and explain. I'm giving this away. Now, I did it quietly. There's a thing at Memorial called STOR, S-T-O-R, where they keep things that people are giving to the world. And I put it there, well, actually in April, and I revised it because Excel got it revised to Excel 16. I made a new version, but I haven't publicly announced it anywhere until today. So this is the first public announcement that it's available. It's there's a PDF, there's an access, a www number inside the paper. Why did I do it this way? Why am I not trying to make money? I'm grateful to the people who created LaTeX, and Patricks, and other things. And these people have graciously given this stuff to the whole world. And I want to give something back. And I don't want to charge students who are poor. I want to let them have it for free, so it's there for the world. I am going to make an announcement to people who teach in this area that it's available if they want to adopt it, no charge. And I have a license to show this. So a lot of you are familiar with open source because that's the equivalent in software, but open access is the equivalent for written documents, and they have this thing where this type of it is the one I want. I'm not making it public domain. I'm just saying you can use it, but you can't steal it. You can't claim it as your own, overwrite my name with your own. You can't make a commercial product out of it. But if you're just using it for non-commercial purposes, I'm giving it away. So thanks very much. Okay.
Yeah. One by one.
Well, thank you. First, thank you very much for your contribution. And second, I understand it's too late, but you could save some money and some time if you ask the question. First, you don't need to buy anything to crop PDF. In the standard text distribution, we have a common PDF crop which does this for you.
Oh, excellent.
Yes, and second, in Patricks as in TXC, you can actually tell that you want to label a line, and you want line to be parallel to the. You want label to parallel to the line. So you can say, you can just say one line, just one comment. I want this label to be above the line and parallel. It will do. So you don't need to do any trick. But I understand it's fun to do trick stuff anyway.
Yeah.
So I. Okay.
Well, thanks for letting me know that. Yes, I appreciate hearing that. Thank you.
Yeah, I think if the sources are online and other people look into it, I mean, there will be more suggestions anyway to optimize this.
Let me just plug one thing. I want to plug techstackexchange.com, where you can ask this question,
yes.
and lots of nice people will answer
yes.
them and save you a lot of time and money. Just go.
Okay.
Yeah.
You are distributing the PDF, right?
Yes, that's right. Because there's no actual physical book. Right. And one reason for that is that I want to update this, say, annually. I don't want to have books climbing around for years, and I don't want to get in the book publishing industry. So it's a free PDF, and it's meant to be used. Oh my! Because there's all sorts of hyperlinks. I should just show you the book itself. I got a moment. So there's the book. So I mean, obviously on the side you've got the table of contents, and if I go to the the index has all the hyperlinks to all this sort of stuff. I click on something that takes me to that page. So I think the book is kind of friendly for having in PDF format, and if you make a book form, you lose all that, and of course if you don't print it in color, you lose the color too as well. So I'm happy with it in this format.
A couple comments. One is just you were showing us a bunch of tables, and I've been like you making tables in TeX and LaTeX for a long time, and I discovered the book tab package, which is one you might want to look at just for slightly more clear formatting of tabular information. The other comment, which I think is probably more important, is that I know that the BC government is interested in creating a repository of free textbooks, and this sounds like it's mainstream enough business stuff that the BC government may actually have some interest in taking your material and putting it in its repository.
Actually, I was asked that by someone, the librarian at Memorial said, could this go on to, they asked, could the BC online thing have it? And I said, they certainly can as far as I'm concerned. I just want to make sure Memorial University had no objection to that. And they said, okay, I'll check with the relevant person, and then I never heard back. So, but I will look into that.
Yeah, I think I have also a comment. I mean, you said you are putting up the PDF since you have it already under the CC by no as a non-commercial. It would be nice if you put also up the source code, because people can then look into it, improve it, send you suggestions easily. It's a suggestion for my case. You only can win if you put up the source code, because you have it already under a license that allows the people to copy. So, I mean, they can still copy from your book. So it's definitely, I think it's a good idea, and I like also the idea to contribute. There's a lot of activity. I mean, friends of mine creating open source textbooks in Logic in Canada, because there is a huge, as you mentioned, the prices are, I mean, impossible for students to pay. I mean, this is completely process. So this is a very nice project. I would like to see also the source code and see this kind of activities proliferate.
Yeah, on the source code thing, of course there's scores of text files, and then there's all the stuff from the Patricks and so forth. It's a big job, whereas the PDF is one file, and the other thing is 70 files, you know, that's,
you don't have to distribute like this. I mean, I would put it in a GitHub or whatever in one distribution. People can look at it, people can suggest you how to optimize, how to improve, like we had here, better representation of some tables or something. I mean, it's only, I think it would be a great improvement for this very nice project.
Okay, thank you very much.
And if you need help for this, I mean, I think many people here would like to help you for this.
Oh, thank you. Okay.
Okay, last talk for this morning. Christian Gagné on Emacs. Yeah, that's nice.
No, this fell down. Do you want to? Do you need this?
No, this is good.
No.
Thanks. I do have a VGA output.
Okay, that's perfect.
My laptop is very businessy, so that's and
should I connect it or?
yeah, and does it only do mirroring, or can I have both displays showing separate?
This is up to your software, computer software. I think this is not the team.
Yeah, you're right. Oh yeah, I have to set it up. Okay, because I want to keep. I'm sorry. I'm gonna demirror the displays because I do need to have my own display here. Oh, I can only mirror the displays, I think. Okay. I don't think I can display separate content on my integrated display and on the projector. Okay. So, I'll just try one more thing. That's what I want. Good. Perfect. Okay. So I have to speak here, right?
Yeah.
Okay. I'll just put this here. Wait, I guess it's, I think it's all right. Okay, thanks. Good. Yep. Good. Okay. I'm currently transitioning from academia into industry, hopefully. So what I will present today concerns my almost completed activities as a graduate student. Because during my philosophy studies, which will soon be completed, hopefully, I was lured into a medieval studies research unit, and I became their IT guy. At that point, I was already a confirmed tech user. I had been for about 4 years, because at first I worked in a different research unit, and I wanted to use tech to typeset an index. My new medieval interest involved taming the XML beast. I happily obliged. However, the road ended back into a distinctly tech-flavored abode. And today, in fact, I will present some topographic examples because I know that Bachelor Tech earlier this year was about tech coming out of the closet, and I think that's wonderful because I want to work in the web industry, and I do want to continue using my beloved tools on the web. So what I'll be showing is how I have done some of that in academia and how I want to continue doing that in industry also. So my first job in the Medieval Studies Research Unit was to teach my literary colleagues to write in a format other than Word or LibreOffice. I was fortunate enough to have the liberty of using LibreOffice in my previous work, and my colleagues were already converted to it. And I do like LibreOffice because it is structured, more so than Word, I would say. Even though it is fully graphical, fully WYSIWYG, LibreOffice is very structured, and it did allow me to do much of what I wanted. And because I love the interplay of theory and practice, I organized workshops for my colleagues as I pursued my gradual discovery of theoretical computer science at the time, and the philosophy of language, and what Edward Tufte calls analytic design. It was also in that school year, that was the 2013-2014 school year, that I began using Emacs in earnest, printing out reference cards and practicing proper buffer movement. What led me to Emacs was first AUC Tech, and then org. With AUC Tech, I first realized how much the dynamics of writing matter. Here I was, teaching my colleagues to write Markdown now and TEI XML, by hand at first, just as I had fully realized the joys of macros. So, however, when I tried to introduce this to their workflow, it seemed to them one step too far. And they said, no. They preferred writing XML by hand, actually. And they were intimidated by transformations and macro expansions of any kind. Such as one of the reasons behind the hybrid workflow we adopted for our research unit's website, which I'll be presenting in a few moments. So I told them, it's up to you. At the time, brackets and other free web editors were coming out, so it was a good time, actually. The conjecture was good. So I told them, yes, you can use brackets to write your XML transcriptions of manuscripts, that's good, and also your bibliography, etc., and I will integrate the content. I took it upon myself, and I applied a saying I read once somewhere: be liberal in what you accept and conservative in what you send. I believe that an earlier version of the conference program made space for an in memoriam for the late Sebastian Ratz. This is quite appropriate, as I am very thankful for the pioneering work of Sebastian Ratz and others in the same field. I will show you in a few moments how I have interpreted the text encoding initiative guidelines and gotten much mileage out of them, but in a perhaps unorthodox way. So first I'll show you an example, a three-way comparison of text laid out in native HTML by the browser and the same content as laid out by TeX using two different inclusions. Okay, I'll have to close this here. Okay, so this is something I reflected upon as I worked with my colleagues. With highly structured notations such as XML, the verbosity might actually be embraced if the material is narrative, with both long stretches of linear sequences and arbitrary depth in some places, and not so many places actually with the case of our manuscripts. The depth is often the result of aesthetic goals that require many levels of tag nesting, which might indeed create a welter of delimiters. And here I am paraphrasing Barbara Beaton, who is said to complain about welters of LaTeX braces in modern styles. So this, the first version of the paragraph, is HTML. So we can select the text here. I have I have gotten into the habit of including key pieces of content in SVG. I typeset the text with LaTeX with a standalone environment, and I convert it to SVG. At first, I was using Inkscape in order to convert the text to paths, because I know that not all browsers display SVG fonts correctly, but Firefox does for the most part. So this is text-to-path SVG conversion, and this here is DVI SVGM, keeping the text intact as text. So there are many nodes in the XML here, and that's why Firefox has some interruptions in its selection. You can see some thin white lines. So this is the best of both worlds, and I find myself wanting to do that more and more often, because this is very intuitive for the visitor to the website, because they can still do what they were doing with text since day one of the web browser. But also, the layout is made by TeX, so I could even use microtype. I don't think I have used microtype in this particular instance, but maybe the difference wouldn't be that great. So there is no hyphenation, so it's arguably better than the one on top. But Firefox still has some acceptable layout choices in general. But why not add some micro-optimizations when possible? And now I'm coming to the tools I have been using with my colleagues. They have been using Markdown and XML in a web editor directly, and I have been using org and Emacs. Markdown and org share the ability to create implicit tree structures with numbered headings, for example. Because as the text is being parsed, tree structures are created in the editor itself. This is applicable in many situations. However, for my scenario, I needed to name my content blocks using native HTML5 vocabulary, because we are doing a XHTML5 website. It is the XML syntax, but the HTML5 vocabulary. And this was important for us, so that we could use the appropriate vocabulary and avoid the excessive nesting that was a mainstay of early web development with divs inside divs inside divs inside divs. We don't have any of that. I could not commit with my content to regular section titles that would convert to H1 to H6 elements, HTML elements. That's because the content blocks had to be arbitrarily nestable. They had to be closed under inclusion, if you will allow my tongue-in-cheek borrowing of theoretical vocabulary. I I call this working content out instead of canvas in, after the expressions consecrated by information architects gravitating around such publications as A List Apart and Boxes and Arrows. So I did the following. This is a very simple example of org mode. It has a very rich syntax, and I only use a small subset. I'm not using any of the planner calendar features, only the markup for rich export, as they say. And I have arranged a quick pretty printing in the algo-like publication syntax tradition, because I like, instead of colors, I like to use different fonts for different keywords and parts of the code. So here I am only showing prose paragraphs, but I would be doing this with Python code also, for example. I like to use a different font that still fits with the main one for keywords, for defined names. So for example, the main text is here in Characel, which is a modern version of Bitstring Charter, and I use Palatino, well, Pagella actually, for the keywords. And in Consolata, of course, for the typewriter font. And so org has a distinction between greater elements, which are special blocks, delimited by begin and pairs as the ones here. There are elements, which is the level of the paragraph, and the paragraph is called the atom in org, and I think that's quite befitting. So these are properly parsed as paragraphs, and they are nested inside the blocks. And there is here a header inside a section, so this gets converted into a HTML5 header inside a HTML5 section without divs. And also, if I choose LaTeX as my export target, the appropriate LaTeX delimiters will be used. And under the level of elements, such as paragraphs, there are objects. And this is what distinguishes org from Markdown, for example. You can have lexical macros at the level of objects in org. And I love this because I often find myself writing very lengthy sequences of nested elements at the inline level, really, below the block level. This is more common in the humanities, I think. Well, that's my experience. In the humanities, people often find very specific use cases for, well, different font families often, but also just, well, the very familiar emphasis example, because the amp command in LaTeX is context aware and will display Roman if the text was already Italic, etc. We have many such use cases in my research unit, at least. So this is the integration that I have been doing. I have been converting my colleagues' Markdown and HTML and reworking it in org, which gives me really the best crossroads, because then I can target any format that org supports, and because org exports to Lisp first, you can really do anything. I have not yet gotten around to writing my own Emacs Lisp, but at the end I'll make a pledge concerning that, actually, because I would like to get into that, but I have not yet had well, I do have the incentive, but, well, you can only do so much in one semester. And now I will show you the results on our website. I'm going to, I think, oh, I can reach it. Where's my cursor? I'll take back the, I'll bring the window back afterwards. Okay. So, my colleagues made TEI XML transcriptions of late 15th century manuscripts. And at first I could not justify the inclusion of facsimile, but I did find a very beautiful font called Givry, which is a very authentic recreation of late 15th century semi-formal hands. So what we have here is the incipit of a French manuscript. The text is a universal history, which means it starts with the creation of the world and goes all the way up to the 15th century. So, very lengthy tomes. And I would not, for now, be able to make a facsimile of the whole book. But this is my proof of concept, really. And beside what we have is actually informal, I was going to say BNF, not BNF, RDF, Resource Description Framework. And eventually, when I do include the SVG as text, the Resource Description Framework sentences, the formal logic included as metadata, will be included directly in the SVG text. So we won't need to put it just side by side so that it is graphically related. It will be logically related as well. Now, please allow me a few comments about the topography here. First, I will cite the opening chapter of Robert Bringhurst's The Elements of Topographic Style, chapter Harmony and Counterpoint, because it's very appropriate in this case. It says here, the early Renaissance typographers set each book in a single font, that is, one face and one size, supplemented by hand-drawn or especially engraved large initial letters for the openings of chapters. Their pages show what sensuous evenness of texture and variety of rhythm can be attained with a single font of type, very much greater than on a typewriter, where letters have, more often than not, a single width and a single stroke weight, as well as a single size. Indeed, and this is not, the original manuscript is not typeset, it is handwritten, but the late 15th century manuscripts are very much the model for the incunabula, the first printed books, which use very similar fonts. More often than not, the books used formal, very upright fonts, but also sometimes semi-formal ones like Givry here. And the Givry font is very similar to the hand of the scribe for this very manuscript. Maybe this is too small right now. I'm not sure if I can zoom in. If I can't, I do have a screen print of this. Oh, I can zoom in. Okay. So it's not identical by far, but as you can see, we could approximate the evenness of texture, in fact, and the very rhythmic composition with diacritics, which were, as Kevin Larson said yesterday, at the time, diacritics and punctuation in general were not standard in any way, and that was good actually for them, because this allowed the scribe to add rhythm and a graphical harmony to the text, according to the circumstances, and also according to the content, which is fascinating. And I believe in the power of harmony, so this speaks to me, really. And also, in fact, at the time, in the late 15th century, there were contemporary developments in logic, which led to the first prototypical models of statements as discrete quantities, and interword spaces at the time were very much becoming standard. But the comparison I'm making here is perhaps an inquiry for another day, actually. So, this is what we have achieved with very few technical means, actually, because I was the only IT guy, as I said, no other programmer or coder on the team. My colleagues were happy with the results. They thought they had gone as far as they would in the available time. They would not have enjoyed writing org or anything like that, even though one of the reasons why I had chosen org was because it does not involve the command line. Even on Windows or OS X, you can actually just use Emacs without ever having to go to the terminal or PowerShell or any other command line environment. So my professor, in fact, decided to try out org, and she was very much interested in the keyboard macros and how you can very quickly include HTML elements. But I don't know if she fully converted her workflow. She's a very devoted tech shop user, in fact. But I'm very grateful for the opportunity that she gave me, and there was a lot of well, it was a leap of faith, really, because at first we did not know the exact scope of the project, and we were supposed to be helped by another professor in France at the Paris 13 University, and then at the last minute he had to completely pull out of the project because he did not get the funding he required in France, so he could not spare any time for us, etc., etc. And well, I know that these things always happen, but for a time I was dismayed because I had to move around and say, okay, no more XQuery, no more XSLT programming, then we'll just use some very accessible tools. I know that most people would have used XSLT for what we've been doing. For example, Sébastien Gras was a pioneer of using XSLT to process XML and generate web pages, etc. But in fact, heresy of heresies, we have included ITEI directly inside our HTML. This is why we are using the XML syntax. Because this is allowed, in fact, and it's a little known fact, that you can really use any XML vocabulary inside XHTML5. I'm having a hard time locating my mouse cursor right now. Okay. Whew. I've lost it again. I'm sorry. Okay. So this is a transcription. It's very seamless because this is HTML. The TEI starts here, and you couldn't really tell, right? This is taking too much space here right now, but and it really is only CSS. So, for example, we are, okay, so this is the TEI starting here, and above it we just have a HTML5 article with a header, and all browsers, to the best of my knowledge, accept this without any problem. Even Microsoft Edge. So I was very surprised. It seems to be working very well. So I wish them the best if they want to add more pages, because in fact the project is only in its infancy. Now that the technical background is complete, we can think about adding more manuscripts. And as for myself, as a future web worker, I really want to keep using org and, in fact, tech-produced content. But I'm not that committed to Emacs, in fact, because I know that when I will eventually work in a corporate environment, my colleagues will have very well-established solutions, and they might be using brackets, Visual Studio Code, or atom, and I just want to be able to keep using macros, lexical macros, tech macros, and really substitution in general. So my parting words for you are that also by studying computer science this year, I came to realize the power of substitution in general, and it's really a general model because for example, I know that Leslie Lamport himself is one of the pioneers in modern equational logic. And in equational logic, well, equality is not even the most fundamental thing. It is defined in terms of substitution. So macros are a very general thing indeed. And in my example here, well, we can see it's not overwhelming here, but the org syntax is verbose in a sense. So since I was exposed this year to equational logic syntax, I thought maybe we could use the same kind of postscript notation for substitution. So this is equivalent to the preceding org example, but here the delimiters are the same ones that would be used for substitution in an equational logic sentence. And interestingly, it's the reverse of the markdown link syntax. Instead of brackets, parentheses, it's parentheses, brackets. So that might be a good point or not, depending on your point of view. But really, in the long term, I would like to implement either Emacs Lisp or something like that to do these substitutions and keep the same multi-target workflow that I already have. And also, I am working on a Python module to do the same kind of task in a general purpose programming language. Hopefully I'll be able to put up the repository soon. Thank you.
Short time for questions.
Yeah.
Hi, thank you very much, Christian. In Ontario, we have legislation that requires websites to be accessible in terms of screen readers.
Yes.
The resulting web content, do you know if this is something that is easily read by screen readers?
I have read articles recently about SVG as implemented by modern browsers. It is accessible, and additional metadata can be added. It's called ARIA. This makes it fully accessible. So even though the text sequences are very deep in terms of the number of nodes, the whole sequence can be flattened again so that it can be read by a screen reader. So there is no loss of accessibility in principle.
One more short question.
We have the break right after, so we can pass
Yes.
to Christian.
Yeah.
Quick question, relationship between displaying on the screen and displaying on paper. Do you think your system is easily adaptable to actual typesetting on paper, especially in respect to the tags that you're using? It's interesting that you're trying to use HTML5 as the basis. Clearly, when you go to paper, you've got more flexibility. You don't have to constrain yourself to HTML5. But are you dealing with that sort of thing?
Indeed. At first, when I started the project, I thought we would be printing something. So I looked at the possibility of typesetting the HTML5, the whole graphical objects that the browser is displaying with tech. But this is deceptively simple when said like that, because actually the graphical objects built by the browser are not fully comprehended by the DOM, the document object model. There are other things. For example, if you add content with CSS, this is not part of the DOM. So that would mean implementing CSS in tech, really, and that's one of my pipe dreams, really.
Okay.
Yeah.
Thanks a lot.